Okay. Okay, so good morning to all of you. Thank you. And I don't know what you have got, but I would start. You can see the syllabus here. We have basically 4 units. Okay. First one is the basic descriptive statistics, mean, median, mode, and measures of central tendency as well as measures of dispersons. Okay. Second is the this regression analysis, correlation and regression. So I would start from this. I would assume that you have already done this first unit. Okay, I would start from unit 2. Okay, and I will show you this. You can say PPTs for this lesson 3. Okay, in your material, it is lesson 3. There are 2 lessons you can say devoted to this unit, lesson 3 and 4. So in lesson 3 we have the correlation analysis. Okay, so we will discuss this correlation part first, and then we will discuss, if time permits, then we will discuss the regression also. So there are 2 parts, one is the correlation and then the regression analysis. Okay, so first of all, what is this correlation? Okay, why we study the correlation, what are its advantages? So correlation is basically, you can say, you have to find the relationship between 2 variables. Okay, the 2 variables, like it may be sales and the demand. Okay, it may be the height and weight of students. So we have to find the relationship between height and weight. Yes. Okay, height and weight. So what is the relationship between these 2 variables? So these 2 variables can be anything in real life. Okay, and it is also that we may have more than 2 variables. Okay, suppose the demand may depend upon price, the demand may depend upon advertisement. Okay, so demand may depend upon more than 2 variables or 3 variable or 4 variable. So then we have to find the correlation between all these variables basically. But time being, here we have to restrict only for 2 variable. Okay, what is the relationship between 2 variable? Later on we would extend it for multiple variables. Okay. So initially you should know the how you can find the relationship between 2 variables. So that is the correlation basically, and further we have to find here only the linear relationship, because the relationship can be of different types. It may be non-linear. Okay, it may be linear, it may be non-linear. So we would again restrict here only for linear relationship. So linearity, I hope you understand. Linear relationship means if there is change in 1 unit in y, the corresponding change, the change should be only linear. Okay, it should not be like if you have some relationship like y equal to x square, or y equal to e power raised to power x, or y equal to sin x. These are not linear relationship. If you have y equal to 3x, 2x, or y equal to x plus 1, y equal to 3x minus 1, these all are kind of linear relationship. Okay, so how the x and y are related? So first of all, we would go again, you can say correlation. So you can see the correlation can be of different types. It can be of positive correlation, it can be of negative correlation, linear, non-linear, already we discussed. Then we have simple, multiple and partial correlation. Okay, so positive negative correlation means when 2 variables are related positively, means that if x increases then y also increases. If x decreases then y also decreases. So this is the positive correlation. Okay. And what is the negative? If x increase while y decrease, or vice versa, then it is called negative correlation. Okay. So if you increase the price, the demand would decrease. So usually that there is a negative correlation between demand and price of any commodity. Okay, if height increases, usually weight also increases. So you can say this is the positive correlation between height and weight. Okay. Now linear already we discussed. Then we have simple correlation. Simple correlation means when we discuss only about 2 variables. Okay, the relationship between two variables. Multiple means when we have more than two variables. Okay, and partial correlation when there are suppose three variables, when demand is depend upon you can say price and budget, but we are looking only the effect of either you can say price or budget, keeping other one constant, that is the partial correlation. Further, how you can find the relationship now? You know there is a correlation, or you want to determine whether there is a correlation or not between two variables, then how would you calculate, how would you find? Because you need something numerical, okay, some numeric value. I know there is a relationship between two variables, but how you can find that one? Okay, so there are some methods. Number one, graphical method. Okay, if you simply plot, if you have some data between two variables like height and weight of all these students, suppose there are 50 students suppose, and I have the data of height and weight, and I simply plot on the graph paper. Okay, taking on x axis suppose height and on y axis weight, or vice versa, you can take as you want x and y. Okay, so if you plot a scatter diagram, or you can say scatter plot, simply graph, if you plot between these two variables, so you would find something like that. If you find something like that which has some positive slope, okay, it is a kind of line. If you fit a line in these points, you get a simple linear line having positive slope. So it means you have positive relationship. That means if x increase, then y is also increasing. Okay, similarly, if you have this type of shape which has the negative slope, I'm sure you must have studied the slope in 10th or 12th class. Okay, so negative slope. So this has the negative slope, you can see. So why it has negative? Because if x increases, the y is decreasing. If x is increasing, y is decreasing. So this shows the negative relationship or negative correlation between two variables. Further, if you have this type of relation, that means you are not sure what is happening. If you increase x, then y may be random. Sometimes it is increasing, sometimes it may be decreasing, or sometimes it may be constant. Then what would you call this? You can say there is no relationship between the two variables. Okay, so if some variable is you can say taking some its value, then the y is not responding, you can say. Okay, so then you can say both variables are unrelated. There is no relationship between the two variable. Okay, now this is the graphical method, or you can say through graph or scatter plot you can easily find a tentative relationship. Okay, you can only find there is a relation, there is a good relation or not, you can also find, but you again you can not find the numerical value. We want something concrete. Okay, if this is the value, then we can find, okay, this much is the relationship. Okay, so now you have to measure that amount of relationship between the two variables with the help of some formulas. Okay, so we have, you can say, some this measures of linear relationship between two variables. Okay, so now we have to find the correlation between two variables using some formula, or you can say some measures. So we have basically three measures. One is the covariance. Okay, then we have the coefficient of correlation, and third is the coefficient of determination. So we have three measures to calculate the linear relationship between two variables. Okay, so first is the covariance. So what is covariance? Covariance is, you can say again, it measures the strength of linear relationship or amount of relationship between the two variables. Okay, and its formula is very simple. If you see the its formula, this is its formula, covariance. Okay, between x and y. If you have the data, okay, x and y, simply you have to multiply x I minus x bar. X bar is the mean, y bar is also mean. Okay, and you have to multiply all these and add this and divide by n. So you get the covariance between two variables. Further, if you can simplify this formula, this is the one form and this is the another form. Okay, if you multiply x minus x bar into y minus y bar, you get this formula. Okay, so both formulas are same. As you feel comfortable, you can calculate or find your covariance. Okay, finally we have two types of formula. One is the population covariance and other is the sample covariance. Now you can see what is the difference between sample and population. And in sample covariance we have in denominator we have n minus 1 instead of n. Okay, this is the only difference, because what happens whenever we have to find the correlation between two variables, usually in statistics what we do, we have to find the correlation between two variables of the entire population. Suppose I have to find the correlation between height and weight of BBA students. Okay, so suppose there are 2000 BBA students and I cannot find the height and weight of the entire, you can say, students. Then what we do, I would take a sample. Suppose sample of 30 students. Only randomly I would select from all the entire batch. Okay, so I would find the covariance of the sample, not the population. If you have the entire population, then use the above formula, and if you have the sample, then you have to find this formula. Okay, so if you have to estimate your population covariance, then you need the sample and you have to find the covariance of only sample, and then you test with the hypothesis whether calculated covariance is correct or not. Okay, so this we will discuss in unit your next unit 5th and 6th, I hope. Okay, where you have to study the hypothesis testings. Although something is also mentioned in this unit also about this. So covariance is a very important, you can say, measure. Okay, which depicts the linear relationship between two variables, and you can see the examples. It's very simple, x value and y value. Okay, and you have to find covariance. You find simply mean of the two. Okay, and find this formula x I minus x bar, like 5 minus 9, then 4 7 minus 9, similarly this 4 minus 8, and you have to multiply. Okay, you have to multiply the deviations of each observation from its respective mean, and then you add it and you divide it by the total number of observation, divide by 5, and you get 4.4. So 4.4, what is 4.4? This is the covariance between the two variables. Now we have some problems with this covariance. Further, you can see if this covariance is positive, then obviously there is a positive correlation. If it is negative, we have negative correlation. Okay, jitna zyada covariance hoga, you can say this is more, the two variables are strongly, you can say, correlated. Now we have some problem with the covariance. Okay, we have problem with the covariance. Therefore, we have a next measure, which is the coefficient of correlation. Now, what is the problem with this? First of all, this covariance is, you can say, not free from the units. If I say x is suppose height and y is weight, x and y can be any two variables. Okay, so suppose x is height and y is weight. So height is in the centimeter and weight in the kilogram. So this unit 4.4 would be height into weight. स्क्वायर हो जाएगा ना, जैसे हाइट हाइट होता था, हाइट का स्क्वायर सेंटीमीटर स्क्वायर, बट हियर इट इज हाइट एंड वेट, सो हाइट इनटू वेट. So it is not unit free. Covariance is not unit free. That is the problem. Further, it does not have some standard range. Covariance can be anything. It can be 8, it can be 10, it can be 100. depending upon your values of x and y. So it can go, it can take any value, you can say, from minus infinity to plus infinity. So it is very difficult for a layman to understand. If I say covariance is 90, so you cannot figure out how much is the you can say two variables are related. So what is the solution? We have the another measure, that is the coefficient of correlation. Coefficient of correlation is the most important you can say measure to find the relationship between two variables, because it is unit free and it has range. The coefficient of correlation has range -1 to +1. इससे ज़्यादा या कम नहीं हो सकता. Okay, so we have, you can say, another formula, that is the coefficient of correlation, which is unit free as well as it has a certain range, and range is -1 to +1. So if you have +1 value for correlation coefficient, then you can say you have a perfect relationship. If you have -1, again you have a perfect relationship but negative relationship. If you have +1, you have positive relationship. If you have 0, R is 0, then you can say that two variables are unrelated. Okay, there is no relation between the two variable if R is 0. So correlation coefficient is most important. So if we have to write its definition, then you can say it not only tells the direction, but it also tells you the amount of relationship between two variables. And further we have two types of, you can say, correlation coefficient. One is the Goel-Pearson and second is the Spearman's correlation coefficient. We have two formula, you can say, to find the correlation coefficient. First is the Goel-Pearson, and second is the Spearman's. Now what is the difference between the two? First you can see on your screen, this is the Goel-Pearson coefficient of correlation. Okay, and it is depicted, it has notation of R. Usually through R we depict the correlation coefficient. Okay, correlation coefficient between two variable. So R in bracket you can say x comma y. So relationship between two variable. So you can say its formula is, you can say, again you have modified your covariance formula. So you can say its simplest formula, correlation coefficient is equal to covariance between x and y divided by standard deviation of x and standard deviation of y. Covariance xy divided by sigma x sigma y. What is sigma x? Standard deviation of x. And what is standard deviation of x? Variance square of variance, square root of the variance. So I hope you already know how to calculate the variance of any variable. Okay. So if you have to find this, you need to find the variance of x, variance of y, and covariance between x and y, and then you can easily calculate R. So you can see when you divide the covariance by the standard deviation of both the variables, then its value would be restricted to -1 to +1. Further, it is unit free because you have divided with the sigma x and sigma y. So height and weight, suppose we have the two examples, okay, two variable x and y. Okay, so in covariance you have height and weight, and if you divide by height and weight, so it becomes unit free. So always the coefficients are unit free. Whenever say coefficient of this or coefficient of this, so that is unit free. Therefore, this has more utility. Okay. So finally, you can see its formula. Okay. I hope you already know this formula. If you know the formula of covariance and formula of standard deviation, and जो divide by n था, it would cancel out in both, so therefore we don't have divide by n. Okay, because in standard deviation also we have 1 by n, but in square root, so there are two 1 by n in square root, so it would cancel out. Okay, so finally we have this formula, or if you further open it, then you can have this formula. So as per your convenience, you can use the formulas. Okay. So this is about you can say your Goel-Pearson's correlation coefficient. Now you can see for the same example we have calculated the correlation coefficient. So we already find the covariance. Now you can find the sigma x. So this is the formula for standard deviation. First you find the variance. Okay, so variance is 9.2. So if you take the square root of this, you find the variance. Similarly, variance of y you can see 8, and finally you can apply this formula, and it is coming out 0.512 only, no units. And you can see it is between -1 to +1. So since it is plus positive 0.5, so what do you mean? So you can say now there is a positive relation between x and y, and you have now you can use some words. What kind of relationship you have? Positive and moderate relationship. You don't have very strong relationship. If you have value more than 0.7 or 0.8, then you can say you have a strong relationship. If you have exactly 1, you have perfect relationship. इससे better relationship हो नहीं सकती. Okay, if you have value 1. Similarly, if you have -1, negative and perfect. If you have around minus 0.7, you have negative and you can say strong negative relationship. Minus 0.5, again you can say moderate negative, and if you have less than 0.5, you can say weak relationship. You have a relationship but it is not good, it is weak. Further, there are some assumptions also for this correlation coefficient. When you have your data, okay, so there should be some assumptions like the variables must be of type interval scale or ratio scale. I hope you have gone through this in unit 1. There are 4 kinds of data. Okay, you have nominal data, you have ordinal data, you have ratio, and you have interval scale data. So if you have to calculate the correlation coefficient, Pearson's correlation coefficient, then your data must be in the form of ratio or interval only. If your data is in the form of ranks, which is ordinal data, then you cannot calculate the correlation coefficient with this formula. Okay. Further, there must be only linear relationship, because this all we are studying in this correlation, we are studying only the linear relationship. If you have something non-linear, then you cannot find that non-linear relationship with the help of this formula. So you can say your correlation coefficient may be 0, but there may be a relationship between the two variables which is not non-linear. Okay, if you have some other kind of relationship, that it may be there. Okay, R may be 0, so you always keep in mind R only calculates the linear relationship. Further, the variables should be normally distributed. So these are the 3 assumptions. Okay, whenever you are applying or determining the correlation coefficient, then you should keep in mind that your data should follow these 3 assumptions. Further, this is the properties already I explained to you. Again, you can see this. So correlation coefficient always lies between -1 to +1. It is free from any unit, and it is unaffected by change of origin and scale. What do you mean by this? If you change your variable x and y to some other variable, so that is unaffected by this. That means if you change your variable, suppose if you want u x minus 10, v, okay, y minus 5. So the correlation between x and y would be same as correlation between u and v. So that means you can change the origin. So I have changed the origin. I have subtracted 10 from each of x. I have subtracted 5 from each of y. And then you get the new variable u and v. So now you need not to find x and y. You forget x and y. Now you just focus on u and v. Why we are changing the origin? To make calculation simpler. Okay. Yes. फर्क क्यों नहीं पड़ता है? You can derive this because this is the property of the correlation coefficient. Okay, if you know the correlation coefficient formula, as already I have shown to you. Okay, this is your formula. If you change here, instead of x I minus x bar, if you write u I minus u bar, similarly v minus v bar, instead of this, if you change and if you calculate, so it would come out the same. Therefore, it does not make difference. So correlation coefficient is change of independent of change of origin as well as scale. What is scale? Scale means if you divide by mileage 5, divide by 5. So if this division, basically if you divide by some other constant, then again it is independent of change of scale. So if you divide by something, then it is called scale. If you subtract or add something, that it is called origin, basically. So correlation coefficient is independent. You can do all these things if you want to make your calculation simpler, basically. And finally, it is symmetric in nature because it is following normal distribution, so it is symmetric in nature. Further, you should also read this. Okay, the correlation does not mean causation. What do you mean by causation? Anyone? Anyone who have idea? I don't know whether you have gone through this material or not. You must read this. Okay. So that means there may be correlation. Like I am saying, the two variables x and y are related. There may be you when you calculate some you have data and you calculate the r and you find r is coming 0.7. So what do you mean by 0.7? It means there is a good relationship, positive relationship. That means if x would increase, then y would also increase. But there may be correlation, but there may not be any region. You can say behind this the relationship between the two variables. Why it is happening, I don't know. But there is a r is coming something. But what is the region behind that? We don't know. Usually we have region. If y is increases with the increase of x, then there is region. Okay, but sometimes you may not have the region. There may not have any cause. Therefore, cause का ही एक causality बनाएगा. Okay, causation बोल देते हैं या causality. So correlation may be there, but causation may not be there. Okay. So here some examples are given for that. You should go through this. Next is the Spearman's rank correlation. Now, as I told you, we have two types of correlation. One is the Pearson's correlation coefficient and second is the Spearman. Now, how they are different and why we need Spearman now? Okay. देखिए, in Pearson's correlation coefficient, as I already told you, your data must be in ratio or interval scale. That means your data should be perfect. You must have like height, weight, income, price, demand, marks. These types of data is you can say termed as either ratio scale data. But if you have ranks, if you have rank, you don't have the original data. Only suppose you have marks in two subjects. I have the marks of all the you guys. Okay, in two subjects, subject A and subject B, and I don't have the original marks. Instead, I have only the rank. Key. You get rank 1 in subject A, you get the rank 2, rank 3, rank 4, like so on. So when I have these ranks are basically ordinal data. This is not the original data. Okay. If you have original data, you have to convert into ranks. Sometimes we do not have the original data, we have only the ordinal data. Okay. Like you know ki he is better than him. Okay. Ordinal means basically you can calculate ki this person is better than that another person, but how much is better I don't know. Similarly in rank, if you get rank 1, you get rank 2, you get rank 3. So I know ki you are better than her, but how much? You may have got 100 marks, she may have got 40 marks, but still rank 1, rank 2. The difference may be 60, the difference may be only 0.1. Okay, so that is the problem with the ordinal data. So if your data is ordinal, x and y are ordinal, then you cannot use the Spearman's, you cannot use Pearson's correlation coefficient. जो अभी हमने ऊपर करा था, you cannot apply that formula to calculate the data which has in rank form or ordinal form. So the solution is Spearman's correlation coefficient. So you can calculate the Spearman's correlation coefficient for ordinal data. Okay, and the formula is very simple formula: 1 minus 6 sigma di square divided by n into n square minus 1. Now what is di? Di is the difference between ranks. Difference between di is the difference between ranks of two variable. So square it, add it, divide by n. N is the total number of observations. So for example, you can say this is your formula. There are, you can say this, I think 10 records, 10 data sets we have, 10 stocks you can say. Okay, and the some experts, there are two experts who rate them. Okay, so expert one rate ki B would be the first one, the best one. You can say C would be the second one. Okay, second rank, and so on. Similarly, expert twos are ranked different. Now I want to find whether there is any relationship between the opinions of two experts. If there is any relationship between the opinion given by two experts. Okay, so I cannot use here the Pearson's correlation coefficient formula. अगर आप वो यूज करेंगे तो गलत हो जाएगा, because this data is in the form of ranks. So first of all, whenever there is a question, you have to understand what kind of data you have. Okay, now how would you calculate? Simply because already ranks are there. Okay, and you have to clearly see whether the ranks are already given or not. If sometimes you have to calculate the correlation coefficient using the Spearman's formula, and the data is given not in the rank form but it is given in the ratio form. मान लीजिए मार्क्स गिवन है आपको, तो you need to convert into ranks then. Okay, so ऐसा नहीं है कि उसको आप correlation Pearson से नहीं कर सकते थे. You can do with the Pearson also, but if I have asked you specifically कि नहीं आप इसमें Spearman's लगाइए, तो then you need to convert first ratio to rank form. Although उसका कोई utility नहीं है, but just to understand you कि how would you rank. Okay, if you have original data, if you have the best data, then why you are using Spearman? Spearman correlation coefficient formula is a substandard formula, and you use it only when you can say when you cannot use Pearson. Okay, so here because we have the rank data, so just calculate the difference of the ranks. D is the difference, square it, add it. So total square addition of the squares of the difference of the ranks is 28. Total n is 10, and apply the simple formula and you get 0.83. So again you can say there is a positive relationship, strong positive relationship between the opinions given by two experts about the stocks. What do you mean by positive relationship? That means that both experts are of same type kind of. Okay, their opinions does not change, it is not changing. If I am saying, if some person is saying this stock is good, then other is also saying this is good. Okay. So this is the meaning of you can say 0.83 here. Further, here in this Spearman's correlation coefficient, we have some modified formula also, and you have to use this when we have problem with the ranks. That means when we have the tied ranks. So what is the tied ranks? I will explain with the help of this example. So you can see this is the data, and you have to calculate the rank correlation. You may be asked, you have to calculate the rank correlation, or you may be asked, you have to find the Spearman's correlation coefficient. One and same thing. Spearman's correlation coefficient or rank correlation, एक ही बात है. Now, if it is suppose you have problem or you have been assigned कि calculate the correlation coefficient. अगर मैं यहां से ये वर्ड हटा देता हूं रैंक, I just say calculate the correlation coefficient, then it's you should calculate the correlation coefficient given by Pearson. तब आपको रैंक नहीं करना है. ऑल्दो आप रैंक भी कर लोगे क्योंकि गलत नहीं होगा, क्योंकि मैंने मेंशन नहीं किया है कि आपको कौन सा निकालना है. बट इफ आई मेंशन स्पेसिफिकली कि आपको यहाँ पे रैंक निकालना है, तो रैंक, क्योंकि ये जो डेटा है, दिस डेटा इज रेशियो स्केल डेटा. रेशियो स्केल डेटा है तो यू ऑलवेज गो फॉर पियर्सन. बट स्पेसिफिकली आपसे रैंक पूछा गया है, तो अब आप क्या करोगे? फर्स्ट ऑफ ऑल यू वुड फाइंड द रैंक. यहाँ पे रैंक्स नहीं दिए, यू नीड टू कैलकुलेट फर्स्ट ऑफ ऑल रैंक्स. जबकि अभी जो प्रीवियस एग्जांपल हमने किया उसमें क्या था, ऑलरेडी रैंक्स थे, तो वो एक स्टेप आपका बच किया गया. बल्कि एक्चुअली रैंक, इफ योर डेटा इज इन रैंक, देन यू ओनली अप्लाई द स्पीयरमैन फार्मूला. बट हियर you can apply both. Okay, ideally you should go for Pearson's, but it is asked you have to find the rank correlation. Okay, then convert into the rank. So how would you assign the rank? How would you assign the rank? हाँ जी, रैंक कैसे देंगे? No one has idea. R2 नहीं, रैंक से सबसे पहले मैंने कहा ना यू, हाँ जी बिल्कुल, स्मॉलेस्ट वैल्यू को रैंक आप 1 देंगे, फिर उससे नेक्स्ट को सेकंड देंगे, एंड सो ऑन. नहीं, अरेंज नहीं करेंगे. उसकी दिक्कत क्या है, देयर आर 2 वेरिएबल नाउ, एक्स एंड वाई. तो अरेंज करोगे तो प्रॉब्लम हो जाएगी. ठीक है, तो हाउ वुड यू अरेंज? देखिए जैसे यहाँ पे मैं कुछ जितना पॉसिबल, सबसे स्मॉलेस्ट वैल्यू क्या है, व्हाट इज द स्मॉलेस्ट? 10. तो गिव रैंक 1. ओके, इसको आप 1 दे दें. हाँ, that I am coming to. Now we have 2 values of 10. That is the problem. 3 values. Okay, there are 3 10, 1 2 and 3. एक यहाँ पे है और एक यहाँ पे है, ये 3 है. ठीक है, यहाँ पे लिख नहीं पाएंगे हम. So what is the solution? If you don't have any tied rank, this is called tied values है ना, टाई हो गया. तो अगर नहीं होता तब तो कोई प्रॉब्लम थी, 1 2 3 and so on. Okay, now we have to give rank like 1 2 3. So you can see 3 ranks are reserved for this. Okay, 1 2 and 3. So what we do, we add all these ranks 1 2 3 and divide by 3, take the mean. So therefore we would assign rank only 2. ये 2 ठीक है, इसको 2 और इसको भी 2. Okay, so we will assign rank 2 to all of the 10 values. 1 किसी को नहीं मिला ना, ये 3 रैंक थे ना, 1 2 3, इन तीनों का मैंने मीन ले लिया. अगर मान लीजिए 2 10 होते तो मैं क्या करता, 1 + 2 डिवाइड बाई 2 यानी 1.5 1.5. ओके. नाउ नेक्स्ट इज आफ्टर दिस 10 के बाद कौन सा है 11. उसको मिल जाएगा 4 क्योंकि 3 यहां तक यूज हो गया है, उसको 4 हो गया. उसके बाद क्या है 5. 12 2 है तो 5 और इसको भी 5, सॉरी 5 और 6 तो इसका 5.5. Similarly, you have to rank all others. You can see the ranking. Similarly, जो मैंने आपको बताई है उसी वे में हमने रैंकिंग करी है. Similarly, you have to do with the y. Okay. ये आपने x का कर दिया पूरा इस टाइप से. आप देख रहे हो यहाँ पे 1 रैंक कहीं पे नहीं है क्योंकि 1 यूटिलाइज हो चुका है 2 में. ओके. 3 कहीं नहीं मिलेगा आपको. फिर आपको 4 मिल रहा है रैंक 4, वो ये 11 के लिए था. ओके. फिर 5 और 6 की जगह 5.5 आ गया. 5 6 7 आपका वो रहा 14 के लिए. फिर 8 9 एंड 10. ओके. सिमिलरली यू कैन गिव रैंक्स टू y वेरिएबल. y को भी हमने वहां पे भी टाई हो रहा है अगर आप देखेंगे ये 1.5 1.5. ओके. नाउ यू हैव टू फाइंड द d बिटवीन द रैंक्स. डिफरेंस बिटवीन द टू वो आ गया d स्क्वायर. d स्क्वायर कितना आ गया 109 एंड 10 है. बट नाउ यू हैव फार्मूला. मॉडिफाइड फार्मूले में क्या करना है whenever there is a tied ranks, now you have to do some adjustment, correction. You can see the correction factor क्या होगा always it is 1 by 12. So what is the correction factor 1 by 12 m3 minus m for each tied rank. Now what is m? M is the number of times the rank is tied. जैसे फर्स्ट 10 कितनी बार टाइड था 3 टाइम्स. सो देयर m1 is 3, m2 is 2 और m3 is also 2. We have 3 tied, 3 टाइज आए ना टोटल. एक 3 बार रिपीट हुआ 10, फिर 11 था वो नेक्स्ट 12 था शायद वो 2 टाइम्स हुआ. और सिमिलरली y में भी एक बार रिपीट हुआ है 2 टाइम्स. तो ये जो 2 थे ये तो x के कोरस्पॉन्डिंग था और ये y के कोरस्पॉन्डिंग. ये रिपीटेशन जो है यू हैव टू फाइंड द करेक्शन फॉर फैक्टर फॉर ईच ऑफ द दिस m1 m2 एंड m3. तो व्हेन यू पुट 3 हियर ये 3 होगा तो क्या बन जाएगा 1 by 12 3 क्यूब माइनस 3. ओके. दिस बिकम 24 डिवाइड बाई 12 it becomes 2. So correction factor for this would be 2 and for this would be 0.5 because when m would be 2 1 by 12 2 का क्यूब minus 2 it becomes 8 minus 6 by 12 यानी 0.5. So correction factor for m equal to 2 would be 0.5. It is always, you need not to calculate if you remember. Correction factor when there is a 2 times tie is 0.5 and correction factor when 3 times 2 4 times होगा तो you can calculate again 4 की पावर क्यूब यानी 64 minus 4 60 divided by 12 5 होगा. So you have to, you can see I have add 109 plus 2 यहाँ पे मैंने ऐड किया ना 2 and 0.5 2 किसके लिए 3 के लिए और इसके दोनों के लिए 0.5 and finally you get the answer which is 0.321. So this is the again positive relationship between the two variable x and y and but weak relationship, not strong, it is some weak relationship. Finally we have the coefficient of determination. Coefficient of determination is the third measure. We have discussed already 2 measure. Number 1 covariance, number 2 correlation coefficient. There are 2 types of correlation coefficient. One is the Spearman one is the Pearson. Now finally the third one is the coefficient of determination. So coefficient of determination is very simple. It is simply, yes. Mm-hmm. This is formula. If you see, this is my formula. Okay. So finally the coefficient of determination. So this is the simply the square of correlation coefficient. Correlation coefficient value lies between -1 to +1, but the coefficient of determination value always lies between 0 to 1. Okay. So if R is the correlation coefficient, then R square would be coefficient of determination. ओके और इसको हम जो डिपिक्ट करते हैं कैपिटल आर से. ओके सो यू कैन से कैपिटल आर. ओके और आर स्क्वायर कह लीजिए. सो दिस इज द कोफिशिएंट ऑफ डिटर्मिनेशन एंड इट इज द स्क्वायर ऑफ द कोरिलेशन कोफिशिएंट. ओके ओके इसको आर स्क्वायर से लिखा हुआ है यहाँ पे, तो यू कैन सी आर स्क्वायर, but in some books it may be R also. Okay, this is just notation, but it is the square of the correlation coefficient. Okay, coefficient of determination, and since its value lies between 0 to 1 only, जबकि correlation coefficient go from -1 to +1, but it goes only from 0 to 1, and you can find now through this you can find the amount, you can compare basically two data. Okay, how much is the relationship, or you can say compare the two series basically. So this helps in that only. Further this also 1 minus you can say this you can say this explains the amount of variation in some dependent variable also. So this is also the another interpretation of the coefficient of determination. So I think this is all about this unit 3, which is which discuss the linear relationship between two variables. How would you find the linear relationship between two variables? So if you have any doubt you can, otherwise I think we can conclude. Yes sir, thank you.